So greetings of the day. Welcome to the course on operations research technique. You are aware that we are in unit number 6 with the concept of simulation. In last lecture we have seen application of Monte Carlo simulation technique for finding waiting time of patients in doctor's chamber and idle time of the doctor. Now today we will see further variety of problems where we can use the same logic to identify other data. So I'll just go through the slides. Now see the problem. I will first read the contents of the problem here. The problem states a company manufactures around 200 mopeds. So it is automobile company. The automobile company manufacturing mopeds and their daily production is 200 mopeds. Depending upon the availability of raw materials and other conditions, daily production has been varying from 196 to 204 units. So targeted production is this one, but depending on this availability of resources, raw material and other condition available for required for manufacturing, their production varies from figure. So 4 less, 4 more than 200. And the probability distribution for this variation is given like this. So how the data is given? So here we can see for 196 mopeds probability value is 0.05. For 197 it is 0.09, like this. So these are individual value of probability distribution for the quantity being produced in particular day. And as given in the problem, it ranges from 196 to 204. Students, if you cross check and add this probability, has to be 1, that we have seen. What is given more in this problem is the finished mopeds are transported in specially designed 3-storied lorry that can accommodate only, now this is important, only so production varies from 196 moped to 204 mopeds, but truck carrying capacity is only 200 mopeds. Truck carrying capacity is only 200 mopeds. So the meaning is, how to treat this? If overproduction, then only 200 mopeds will be transported in that lorry. If it is under production, that is less than 200, then few spaces will be available in the lorry, 3-storied lorry. Using following 15 random number, again in this problem random numbers are given. Using 15 random numbers, and those random numbers are given in 2 digits. Those random numbers are given in 2 digits like 82, 89, 78, 24, 53, 61, like this. These are the 15 numbers given. What is asked? What is asked? Simulate mopeds waiting in the factory. In previous problem we have analyzed the situation for dentist chamber, dentist clinic. Now here what is asked? Simulate the mopeds waiting in the factory. Further, what is asked? What will be the average number of mopeds waiting in the factory? Now to analyze this question, what will be the maximum number of mopeds waiting in the factory? When mopeds will be waiting in the factory? If production is more than 200, if it is 200, no waiting, because all 200 vehicles, mopeds will be transported through that lorry after loading. But if it is 201, one moped will be waiting. If it is 202 production, two mopeds will be waiting. If it is 203 production, three mopeds will be waiting in the factory store. If it is 204 mopeds production, four mopeds will be waiting in the factory store. So that is how the logic of what will be the mopeds waiting. And when we want to find average number, what we do? We'll carry out waiting for all 15 simulation. We'll sum up those waiting. We'll divide that by 15. Will give us average waiting time. Second is, what will be the number of empty spaces in the lorry? So students, how lorry, in which case the lorry will have empty space? Just think, I have already explained. When production is equal to 200, there is no empty space in the lorry, there is no truck waiting, there is no moped waiting in the store. The moment your production goes below 200 mopeds per day, means if it is 196 mopeds production, lorry will have 4 empty spaces. If it is 197 production of moped, lorry will have 3 empty spaces. 198 mopeds production, lorry will have 2 empty spaces. 199 mopeds production, lorry will have 1 empty space. In this way, we will evaluate this problem, and for that again we have to use Monte Carlo simulation method. Wherever there is probability based data, we have to use Monte Carlo simulation. So now here the logic will be, our logic will be, first column will be of course serial number, then followed by production per day, then we'll be having value of probability distribution, then we'll be having value of cumulative, this is very important step, cumulative probability, and then of course range of that particular random number. Whenever we find cumulative probability, we have to find random number range. Now we know, we have a lot of practice, we will be putting this random number in the fashion given. We will be putting this probability under here, and then we will be finding cumulative probability. So in first case, in first table, we will not put this value, first this value will be for finding the weighting, probability distribution, cumulative probability and range. Once we are ready with this table, then we will fix these numbers in that range, and accordingly for that range we will estimate what is the production per day. It goes like that. So let's see how the problem is analyzed. Again, this is the solved problem for you people. I will explain the steps. So production per day, yes, given, varying from 196 to 202 with, this is probability distribution, this is probability distribution, for given situation, for given, this data was given to us in previous slide in problem like this. Now how we have evaluated this? This is, first is same, summation of this is this cumulative, then this cumulative plus this plus this gives you this value, this plus this gives you this value. That mechanism we know, that adding previous probability in existing probability, adding previous probability in existing probability, existing cumulative probability. Here always for first case the cumulative probability will be the first number itself, and then when we proceed we have to add next probability into the cumulative answer. Last must get 1. Last you must get 1. Now once you are ready with this, now see here it is 0.05, cumulative probability is 0.05, and we know that in percent probability is, we are expressing maximum probability 100%, which is equal to 1. 1 multiplied by 100 gives me 100%. 0.5 multiplied by 100 gives me 50%. Now 0.5, 0.2, 0.28, this kind of probability is expressed in terms of fraction, decimals. If I want to convert that in number, what I need to do is multiply it by 100. Similarly, if I multiply this first number 0.05 with 100, it will yield a number 5. It will yield number 5. So cumulative probability is 5. So for 5, to decide range, I have to go one number before 5. So that is 4. So range is 0 to 4. So you can find how you got a range of 0 to 4. Many students get confused and they ask repeatedly, sir, how you arrive from this value of 0.05 a range of 0 to 4. So just explain. Again I will explain. Multiply this 0.05 by 100. It gives you 5 as a cumulative probability. One number prior to 5 is 4. Therefore, for this cumulative probability, your range is 0 to 4. Similarly, 0.14 into 100, 14. One number prior, 13. So in this way, we take for this, it is 6. 6 means 0.59, means 59, 60, 59, last 99. So it is 1 multiplied by 100, one number prior to 100 is 99. So last value of range is 99, and we have to start it from further number. 93 is for previous, so 94 is for next lot. So you have to go in this fashion, like this. I will mark how to go? Jump like this. Like this. This is very important table. Once you are ready with this, now our task remains very simple, and that is what we need to do is we have to see the random number. We have to see in which interval that random number fits. We have to see in which interval that random number fits, and accordingly identify the production, write production pertaining to that random number, and then decide whether unit will be stored in the moped, will be stored in the factory, or will be dispatched, or will there be any empty space in the lorry. So once we are ready with this, next slide explains like this. Now we are given 15 random numbers, and these are the random numbers provided by the examiner. So we are using those random number in sequence, and the number of days to be simulated are based on random number. So this is the simulation for how many days? Simulation for 15 days. Simulation for 15 days. Simulation for 15 days. Now what is important? This random number 82, how to understand this? That is what I am telling. Where from this figure 202 came? Where from this figure 202 came? Where for this figure 203 came? Likewise, if we understand for these two cases, likewise we can get the idea of these numbers. It is sure number will vary from 196 to 204 mopeds, because that is given in the problem, that is mentioned in the problem, that it will vary like that. 196 to 204, that I know there will be variation. We'll check for these two. Remember in mind number 82 and 89. For 82 the figure, remember, it is 202. For 89 remember your figure 203. And we'll go to previous slide. Number 82 and 89. 82, 89. Go to previous slide. 82 number which we kept in mind is 82. One number is 82, other number is 89, and here it was 202 and 203. Now see here, this random number which is 82 falls in the range of 75 to 85. Random number 82 falls in the range of 75 to 82. For 75 to 82 your daily production is 202, and therefore this 202 value is written in the slide. When I solved that problem, 202 value was written. I think it is clear now. Yes. Similarly, check 89. 89, this number 89 is in this range. 89 number is in this range. For this range, production is 203. For this range, production is 203, and therefore 203 is written in production quantity. Students, likewise, all 15 numbers, for all 15 numbers, what was done is it was checked in which particular range, that number lies. What was checked in which particular number that range lies. And once we are through with that range, it is the simply task of pointing towards production quantity. It is only pointing towards production quantity. Now we are ready with days 1 to 15. First column, second column, random number, and third column, important column, for that random number, production quantity. Let's move ahead. We are ready with first column, days, second column, random number, third column, production per day. Just explained how you get this 202, 203. Similar fashion, you get all these remaining values. Now, important table, important column from analysis point of view. If you recall my earlier lecture, there I have said that methodology of Monte Carlo simulation technique will be same. I have many times iterated this particular sentence that methodology of Monte Carlo simulation technique will be same, but for simulation the tabular format will vary as per the data given and analysis asked in the problem. That you must understand. Logic will be same, approach will be same, but your answer will be varying, columns will be varying, table pattern will be varying as per what is expected by the problem for decision making. So here, therefore, keep one thing in mind, try to make the column of that nature for the parameter which was asked in the question. Like in this particular case, what is asked? If you recall, number of mopeds waiting. If I want to evaluate number of mopeds waiting, then I have to have column of that particular parameter. Next is asked in the problem empty spaces. So I made the column of empty space in the lorry. Now, important, keep one figure in your mind that lorry is having capacity of 200 mopeds. Lorry is having capacity of 200 mopeds, whereas these are your daily production. These are your daily production. Now it is but obvious, if I overproduce than capacity of the lorry, if I overproduce than capacity of the lorry, overproduce I mean overproduce than the loading capacity of the lorry, then naturally number of mopeds waiting in the factory will be available for some number. Likewise, for 202 production, this is constant, so 202 minus 200, I am getting 2. How I get 2? So this 2 is a result of what? 2 is a result of 202 minus 200. Clear? Likewise 203 minus 200, 202. Now here you can find dash. Why dash? Because production is less than 200 capacity of loading, so there is no question of waiting, therefore dash. So while marking this column, whenever the production is less than or equal to 200, I am saying whenever the production is less than or equal to 200, we'll put dash. So you can find for 200 it is here, it is written 0 or can be dash. Now 0 is the result of what? 200 minus 200. So exactly there is no scooter waiting in the factory, all will be dispatched. So for 200, to avoid confusion, 200 minus 200, 0. Here if you write in the fashion of 198 minus 200, it will be minus. So minus is not the desirable figure, minus waiting is not possible, and therefore it is written dash. So wherever there is 200 or like that, put dash. If even you put instead of 0 dash, won't harm the final solution. So here it is the quantity, here for this it is dash, 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 and then it is 2, like that. So once you evaluate these values, sum these values, average number of waiting time is sum of all these values upon total number of days. This total number of days are 15. So this individual sum divided by 15 gives you approximately 1 moped per waiting in the factory per day, averagely. That is how we calculate analysis. And last column, empty spaces in the lorry, it's reverse. It's reverse in the sense, if production is less than 200, not exactly, for exactly 200 production, there won't be empty space in the lorry. If production is less than 200, then we will have figure of empty spaces. For 200 and above production value, we'll write empty spaces as dash. So here you can find for these 200 and above empty spaces as dash. Here for, I will use other pen. Here for this 198 you can find empty spaces 2. Here for 198 you can find empty spaces 2. Here for 196 empty 4, 198 2, like that. Now here it should be for 191 number of made, here it should be dash, and here it should be for 199 there will be one empty space, and here 3. So again what you have to do for finding average number of empty spaces in the lorry, add all empty spaces of all days, divide that by 15, you will get the answer of per day empty spaces in the truck. So students, this is also a real life application of Monte Carlo simulation technique in automobile industry. One case in earlier lecture we saw the problem of Monte Carlo simulation approach to doctor. Here, that is, doctor means it is service industry. Here, manufacturing unit. Let's go for other problem. Now, this is the problem. See that with every problem we are analyzing different situation. I will explain what these situations call for. Here the problem is related to bakery. The problem reads as: a bakery keeps stock of popular brand of cake. For me, the important word is stock. I will explain why I am writing this as an important word, stock. A bakery keeps a stock of popular brand of cake. Previous experience shows the daily demand pattern for the item with associated capabilities, which are given below. Now, daily demand. Meaning of daily demand is number, and that is the number of cake. Item is cake. Daily, the demand for cake varies. Distribution is given 0, 10, 20, 30, 40, 50 numbers, and for that demand respective probability is given. You can see over here. For every individual demand of cake, respective probability is given. We know these are the probability distribution, and we sum it, we know it is 1. If I sum it, the probability, the value will be 1. Use following sequence of random number to simulate the demand for next 10 days. 10 days simulation. So students, this problem belongs to the category of inventory. Now we know cake is as such perishable item. What I mean by perishable item is, if I am not in a position to sell that item, if I am not in a position to sell the cake, it will be lost to me. It will be lost to me, and therefore I must precisely have an inventory of those cakes only in my stock for which I am ready to sell. Otherwise, I have to bear a loss, and any shopkeeper will not be happy if he is making loss, since this is perishable item. Now, what is asked in the problem? That you have to simulate the demand, means how much inventory that shopkeeper, bakery owner should have with him for those cakes which are likely to be sold to the customer. Also estimate daily average demand of the cake on the basis of simulated data. This to estimate average is easy. Why it is I am saying easy? Because naturally we will be simulating demand for all these 10 days given in this order of random number. If I am having data of demand of 10 days, if I divide that by 10, it will give me average demand. Again, see, now logic is same, application has changed, area has changed, area of application has changed. Therefore, this particular concept has wide acceptance across industrial scenario in day-to-day life. and therefore this simulation concept is very important for everybody. Now distribution is given. Again, what we have to go for is demand. That I have said, as per given logic, as per given constraint, your tabular form will vary. So probability distribution, second will be probability distribution. Guess next. This is our third problem. Get next. What should be the column? Think little. Yes, has to be cumulative probability. Has to be cumulative probability. And what next? Last, random number range. Random number range. Once we are ready with this data, then further analysis is simple. See here now. Demand we know, probability distribution we know if we sum this it is going to be 1. Then cumulative probability, last it will end with 1. I have mentioned you that we will be multiplying by 100 to find the number, and while deciding the range, one number prior to the current random number range. That is our random number range for each of the demand. So again, calculation done. I will explain the same. This slide, blank slide I have written earlier. So daily demand, yes, we know. Daily demand we know. Then probability we know. This is given. This is given. This is also given. Now this is my work. This is my work, which is very important. We have to carry. So what I have explained in earlier case, same, go on adding. So this is same, this plus this gives you this, then this, add this to this gives this. This is a simple logic which we are using for finding cumulative probability, and last it has to be 1. So simple task, add further probability in previous cumulative probability to get the last value. Now again, how many students they get confused, sir, how this is 0 0, we don't understand the logic. So again, the thing is very simple, students. This is 0.01. If I multiply it by 0.01 by 100, it will be 1. A number prior to 1 is 0. A number prior to 1 is 0, and therefore this range is 0. Therefore this range is 0. This is 21.21. 0.21 multiplied by 100 gives me 21. For 21 prior number is 20, and therefore for this second it is 1 to 20. Likewise, all these ranges are decided. This is very crucial step for finding the parameter of the problem. For this problem of a bakery, we want to estimate the daily demand of cakes for 10 days. Now what will be our task to analyze the problem? What we will do? We will find all these 10 random numbers We'll find all these 10 given random number. We'll check where this falls in this random number range. From that we'll find demand and we'll portray that demand for that random number. So let's look that aspect. Now here this is 10 days to simulate. These are the random numbers given. And now remember again, these two for random number 40 value is 30, for 19 value is 10. We'll check for these two values. We'll try to get how these values, here I have written for you, I have written how I have taken these values, but I will show you. 40, 30, 19, 10. Go to back slide. 40, 30, 40, 30, 19, 10. This is demand and this is random number. We are checking for two cases. So now random number 40. Random number 40. What I'll check? 40 lies in which range? So for me, I can see here 40 lies in this range. 36 to 85, 40 lies. And if I come in this direction, so the demand is 30. And therefore students, here the demand is 30. Simple, but you have to keep that concept in mind. Clear? Then moving one step ahead again, 19. 19 is 19, random number range for 19 is, here it is 1 to 20, so it lies in this range. It lies in this range. Clear? Now focus here, value 10, demand, this 10 demand we have written over here. So this is how, based on random number, you are pointing towards particular demand. Once this is done, come to this slide, and this slide explains us the values of demand for remaining cases. The values of demand for remaining cases. See here. So what was done for remaining cases is, these random numbers, these remaining random numbers, we have seen while backtracking for these two numbers. On the similar ground, for this random number, these demands were identified for that random number through range as per logic of Monte Carlo simulation. And this gives, based on probability of sales, the pattern of distribution, pattern of demand of cake for 10 days, which varies from 30 from day 1 to 10 cake for day 10 with variation in between. And if you sum up, it comes to be 220 cakes. If you sum up, it comes to be 220 cakes for entire 10 days. Now data is available for 10 days simulation. Our intention is to get average time. So this is total cakes over for 10 days total cake demand, actually it is total cake demand for 10 days. What problem has asked? Average demand for 10 days. So simple, 220, the figure of total by 10, it gives 22 units per day. It gives 22 units per day. So likewise, in Monte Carlo simulation technique, we analyze various parameters of the given problem, and then we keep on moving cumulative probability, first probability distribution, cumulative probability, random number range, fitting of the random number fitting, finding corresponding parameter from fitted random number, and then evaluation. So in this third example, what we have seen is the application of the concept of this particular application of Monte Carlo simulation technique in inventory management. In second example, manufacturing unit. Again, that is part of some logic related to inventory. Not exactly inventory, but logistic part, where we have to check availability of space in the factory. In first case, it was doctor's chamber, service industry. And likewise, there are many areas in real life where we can find this concept of Monte Carlo simulation technique in real life. And we can use this concept even for banking purpose. So we'll stop our today's lecture at this point of time, and in next lecture, further lecture, we'll study advanced part of the topic. So till time you practice all these sums.